The broadcast is now starting. All attendees are in listen-only mode.
Welcome everyone to today's webinar entitled Making Developing People, Job 1 in Lean. I'm Scott Shive, Director of Marketing Communications for AME, and I will be your moderator today. Today's presenter is Dr. Jeffrey Leiker. Dr. Leiker is a professor of Industrial and Operations Engineering at the University of Michigan and president of Leiker Lean Advisors, LLC, and also CEO of Leiker Leadership Institute. He's the author of the national bestseller, The Toyota Way, as well as numerous other books, including Toyota's Product Development System and The Toyota Way to Lean Leadership. His articles and books have received 11 Shingo Prizes for research, and Dr. Leiker was also inducted into the AME Hall of Fame in 2012. Before we start, just a couple of housekeeping items. You'll be in listen-only mode throughout the webinar, and you'll see that you are muted on your attendee panel on the right side of your screen. If you have any questions during the webinar, please type them into your question area in the attendee panel and click on the Submit button, and we will review the questions at the end of today's presentation and answer as many as we can. And when you log off today, please check your email inbox. In it will be an invitation and link to fill out a short webinar attendee survey. And please take a few minutes to complete the survey today, as your feedback is very important. And if you do it today, you won't receive a second and third invitation from us asking for you to complete the survey. Dr. Leiker has also graciously agreed to provide a PDF of his presentation, which will be sent to each of you within 48 hours at the conclusion of today's webinar. So without further ado, I'm pleased to introduce Jeffrey Leiker, who will present Making Developing People, Job 1 in Lean. Take it away, Jeff.
Thanks. And thanks all of you for joining us this next hour. Leiker Lean Advisors is my consulting company. I have associates, and we work with organizations throughout the world, coaching and leading them through lean transformation. And the Leiker Leadership Institute is an online training program to teach what's in the book, The Toyota Way to Lean Leadership, which is my most recent book with Gary Convis, who was formerly a managing officer at Toyota. What I'm going to talk about today is developing people, and I'm going to do it through a case example that I hope you'll find interesting. The problem is that lean too often, whether it's deliberate or not, is treated like a toolkit to lean out processes as if a process was a physical thing that you could physically manipulate. So, for example, if we think about a process as a brick wall, somebody might say, let's lean out this brick wall. It has too many bricks, bricks are expensive, and we want a less expensive brick wall, and we might do something like this, eliminate waste. We identify things that we call waste and say, now we've got a leaned out brick wall. And the question here is, would you like this to be holding up your house? And I think the answer would be no. And in fact, often what I see is leaning out really means pulling out people or pulling out inventory when the process is not capable, and therefore we're actually weakening the overall system of delivery to our customers instead of strengthening it. If we think of organizations as if they were physical machines, and we were therefore leaning them out by applying lean tools to eliminate waste, what most people have discovered, well, what we'd like to do is we'd like to then apply the tools, develop a leaner organization, and you can pick whatever organization you want. People talk about how healthcare costs are skyrocketing, and what we need to do is to lean out healthcare. And the implication is that we can, again, apply some tools to healthcare with some smart people who understand lean, and then healthcare will cost less, and it will be leaned out at the new lower level of cost. We would like to at least maintain that low cost now that we're lean. The problem is that we have counter forces to our leaned out system, and we call that organizational entropy, just like physical entropy you'd experience in the world. which is a tendency towards disorder. There's forces out there that want to break down your house over the next few hundred years into rubble laying on the ground. And there's also forces that want to break down any organization structure you create or any standard operating procedures you create. And partly it's people kind of getting bored with things and not wanting to follow the standard operating procedures in a disciplined way. If there's organizational entropy, what I'm showing here is that actually the more lean you become, the greater the organizational entropy, because lean means we have more rules, more procedures, more standards, which requires a more disciplined process. And the more order we create, the more pressure there is from organizational entropy to undo what we put in place. In other words, people don't follow the procedures, people come and go, and new people don't understand the procedures or aren't trained well, don't buy into them. The procedures aren't being continually improved, so they're not adapting to changing circumstances. And many companies have experienced the collapse of lean often within months of some sort of Kaizen event. So what entropy means is decay, and this is what actually happens, and this was well illustrated by one of the Toyota senseis I respect, who says that applying lean like a toolkit is like weeding a garden without pulling the roots. The weeds are simply going to grow back. And then companies ask, why are we slipping? What happened? And the answer was that there was really no counterbalancing force to the natural entropy that occurs. And the counterbalancing force to begin with was the lean team. They came in with their expertise, they came in with their toolkit, they leaned out the process, they might have pushed machines closer together, or they might have created a visual planning room with cards and everything set up, and then they teach people how to use the standardized work, the visual management tools, whatever they set up, do 5S every day. Then the lean team moves to the next implementation area, but the people left behind have not really been developed and don't have ownership of the process and don't understand it enough to continually improve it, and then entropy is going to win, and slipping back is going to be natural. At this point, we're asked, how do we sustain the gains? And the answer is that the approach used to begin with was a bad approach because people were not developed. So the approach itself guaranteed that there would not be sustainment. And at this point, after the fact, there's no magic fix that will undo the damage that's been done through a bad process. What we need instead is to counter the entropy with positive energy, and that positive energy comes from people. Again, if the people who care about lean, who understand lean, who view themselves as the change agents coming in from the outside are the lean team, then the positive energy will be there only as long as the lean team is there at the Gemba where the project was done every day. So in other words, if you were to dedicate a lean team to one area and they never left, they could sustain the gains. But obviously that would be expensive, and companies don't want to do that. They want to spread lean beyond the initial area that the lean team is working in. So the question is, who is there? Who is on the ground? Where does that positive energy come from? And the people on the ground are the people doing the value-added work, as well as the supervisors and managers who manage them. So that's the group that needs to be providing that positive energy for improvement. So what I've done here is recast the lean transformation process so that the early work that's done with the lean team really should be viewed as experimentation for the benefit of teaching the people in that area engaging the people in that area, and generating that positive energy. The positive energy actually comes from having a target that the team agrees on. It could be a target for improved quality, for improved safety, for reduced cost, but there's a target for improvement. Engaging the team in moving toward that target, and then letting the team experience the positive energy that comes from winning the game. And the game is to reach the target, is to improve the process, is to see results, and to realize I was part of the team that got these results. So in the early stage, you're really starting the process sort of like yeast will start the process of bread growing, and you need that yeast, and you need that you need to get started. And once you start the first project, in that process, most likely you don't have a lot of internal lean experts, so they're learning maybe from outside sensei teachers, and then the people who are directly involved, who work in that area, they're learning. And anyone else you bring in, for example, say a manager from the next area where you're going to apply lean, they will also learn from that experiment, from that experience. Then you're in a position to start spreading the learning. You're not spreading the lean tools, you're spreading the learning to other parts of the organization, which can be done, again, if you pull ahead some people, like some managers in one Japanese plant we happen to be working at, the director of operations actually assigned assistant managers from every area of the plant to work in the model area for 6 months, full time. And then at the end of the 6 months, they all went back to their areas. And then my consultant was first consulting in the one area, the model area, then was consulting in all the areas of the plant directly to those assistant managers. And then the next step is to develop some stable base of ownership and skill and knowledge at the work group level, and that's what's called the daily management process, or Toyota now calls it the floor management development system. And that's a daily process of having key performance indicators, having them visually displayed, also having visual standards at the work site, perhaps having the and-on system so you can call for help when there's a problem. And there's a daily process of picking the biggest problem and working on improving that. And you get a daily continuous improvement process at the work group level. And at that point, you have a very sustainable process, and the positive energy will beat out entropy if and only if the leaders have the understanding and the passion. Within Toyota, the work group structure is a group leader who's a supervisor, and then there's some hourly employees who are selected or developed actually to become team leaders. And between the group leader and the team leaders, they provide that positive energy. And a lot of effort is put into both selecting and developing those people. And Toyota would say the team leader, group leader is really the key to sustainment. And it happens at the work group level. The work group is approximately 20 to 25 people. So there are as many work groups as you need to get that ratio of one group leader for about 3 to 4 team leaders for about 20 people. We all know personally from our own experience that as you age, your body is decaying, and now it's become pretty clear that there's 2 ways to combat that: eat less and exercise more. And what we're doing when we work out is we're working to arrest the entropy at the root cause. You don't get to the root cause, for example, by taking diet pills, but you do get to the root cause by exercising in the proper way to actually develop your muscles and develop your body so that it develops faster than entropy. And again, eventually entropy will win with our body. With organizations, new people can be developed as successors as other people age, so organizations don't have to die. Okay, this is the case example I'd like to talk about, and it was a unique experience I had 2 months ago. I was in China speaking, and I stopped in Japan, and I wanted to see interesting new things that Toyota was doing. And one of the things they set up was a visit to their Honsha plant, which Honsha means headquarters, and it's right at the same place where they have the Toyota Motor Corporation headquarters. And this happened to be, what they showed me happened to be a forging plant that kind of bangs out metal engine parts, like say a cylinder head. And this plant had in it one of a tiny number of people who are given the title of Senior Technical Advisor, which is really the highest honor within the Toyota production system in Toyota. Mitsuru Kawai-san was a direct student of Ono. He was actually hired in through Toyota's technical high school. They have their own high school. It's a public high school, but they have a high school in Toyota City, where Toyota is. And they develop people in the high school both for a craftsman track where they learn to work with their hands and very basic skills like repairing machines or grinding or making dies. And then there's also a college track. He was on the craftsman track, and he was hired in as an hourly production worker. Ono saw something in him, took him on as a student. And again, that was 50 years ago, and Kawai-san's been working at Toyota for 50 years, at this particular forging plant for 40 years. He's not the plant manager, but he's the senior technical advisor, and he's got the run of the plant. And this plant has become a model for the Toyota production system. Interesting, he said that in his 50 years, actually the 40 years that he's been at the forging plant, he's had the same productivity target every month, which is 2% productivity improvement. And he was explaining that means that at the end of the month, whatever he's achieved, he goes back to 0. And the next month, he has to work to achieve 2% all over again. Now, one of the ways he's done that, and the plant has become very profitable and very productive, he has used a lot of automation. At first, he was doing it, it was a primarily manual process, and he was doing it through labor productivity. And eventually, he kind of reached the limit of that and began to use automation, which has obviously changed and advanced over the decades. When we talked to him, he said he realized as they're automating that they had a serious problem. And the way he explained it with the automated line, rookie team members think you push a red button and a part comes out. He personally and the people who are older grew up when the process was still manual, and they had learned how to do forging with their hands. When the process became automated, they still understood forging, and they knew what was happening inside the machines. But newer members, engineers and workers, maintenance workers and production workers, they didn't know what was going on inside the box surrounding the machines. So they just push a button, and every few minutes a part pops out. And he said that what they really need to learn is how to apply the Toyota production system to Kaizen automated processes. A lot of the examples of TPS that people hear about, and a lot of experience with TPS in plants, really is in heavily manual jobs. For example, in final assembly in Toyota, there's a lot of work to take out seconds of labor for a given process, and then eventually get a minute worth of work so you can balance out a process or have one less person in the operation. That doesn't make sense in an automated process. So he identified the problem as a gap between the need to understand the Gemba and learn to see waste even inside the automated process, even in the process of machining and then moving parts automatically from machine to machine, and the current understanding of these rookie team members who didn't grow up with that experience. That was the problem we saw. Now notice this is, so again, somebody taught by Ono, and what he identifies as a problem is not a problem with leaning out anything. It's a problem with people development. He's not satisfied that he personally has plenty of knowledge to go around and lean out these automated processes and direct people to do what he tells them to do, because he's been there for 50 years and he knows that he's not going to be there for another 50 years. So he needs to pass on this knowledge, and he also wants, the plant is very large, and there's many machines, and he just can't be every place at once. So he needs to spread this knowledge so that Kaizen is going on throughout the plant without his directly being there and standing there and doing the thinking for everybody. He wants to advise and teach and develop them, not think for them. He defined his target for learning that he wanted the team members, and again, this included engineers, it included repair people, it included production workers, to develop skills through manual work, not through watching automated processes, so that they could visualize production and really be able to mentally picture what's going on inside the machines. He wanted them to develop explicit knowledge, that is knowledge that could be written down, then standardize that knowledge so it could become the standard way we do our work, and also develop intelligent automation, judoka. So he wasn't satisfied with dumb automation, but he wanted automation, for example, like the original automatic loom that Sakichi Toyota developed, automation that would detect problems and shut itself down or call for help when there's a problem. And he wanted this all to be learned at the Gemba. He didn't want to have to pull people into a conference room and give them lectures about how forging works. He also provided an ideal image, and I specifically asked him whether when he joined Toyota 50 years ago, so it's 2013, so that's roughly about 1960, 1963. So, by 1960, there had been a lot of work done on the Toyota production system. TPS started after World War II, seriously. So, say there was about 15 years of work. And I wanted to know, in the 50 years, has he seen a lot of change in the Toyota production system? And he said no. He said nothing has changed. He said by the time he joined the company, Ono and his team had pretty much worked out TPS. So I asked him what he meant by that. I said, for example, I know that today you use electronic Kanban. You didn't have that back then. He said, well, I'm not talking about specific tools. I'm talking about the philosophy, the methodology, and what we're trying to accomplish, and that has not changed in 50 years. And often I get the question, what's new in TPS? What's beyond lean? According to this one expert in Toyota, nothing's new in 50 years, and I'm not sure if there's likely to be anything new in the next 50 years. Again, at the level of the underlying thinking, principles, philosophy. And basically said what we're trying to do 50 years ago and what we're trying to do now is we want materials to be flowing while they're changing shape at the speed we can sell the product. And everything else is waste. That's what we're trying to do. That's what we're trying to do 50 years ago. That's what we're trying to do now. And we want intelligent automation to reduce as much as possible any transportation or movement that does not change the shape or form. So that was kind of interesting, because if you look at an automated line, you can analyze it just like you can analyze a manual assembly line, and you can ask the question, where is value being added? And that's when you're actually pounding the metal, when you're doing the forging. And then any other movement of the material is waste. These were his countermeasures. There's actually a third countermeasure I'll mention briefly, but these are the most, I thought, most interesting. But there are two countermeasures to the problem. Again, the problem was the gap between the level of understanding by the team members of what actually happens inside the machine, what the process really is, where there is waste in this automated process, and the understanding that they would have if they had grown up with the manual process and they had to actually do it by hand, and they had learned TPS and they'd learned to take out waste in the manual process. Then they could fairly easily transfer that understanding to the automated process, but they hadn't had that experience. So his countermeasures were to try to give them that experience in two ways. One he called my machine drawing, and I'll talk about each of these two ways. And the second was transferring an old automated line from, I believe, about 60 years ago from Brazil to the Hansha plant in Japan, so they could actually experience a manual line. The My Machine activity, again, this is something he developed. He asks the worker, and the worker, again, could be a young engineer, it could be production, it could be maintenance, but he asked them to handwrite a document describing how the equipment works. So they have to take off the outer metal so you can see what's happening inside the machine, and they have to, in detail, watch the part move, the material move, and document what's happening second by second by second to that material, and document the actual production process of forging as well as the movement of that material to and from different work centers. And he believed that they can learn better by drawing pictures than by writing words or typing something into a computer. He wanted them to hand draw. And then the other thing he did, which was very clever, is that he had the working level people doing the drawing, and then as they were doing the drawing, he instructed them, when you have a question and you don't understand something, ask the supervisors and managers. He knew full well that the supervisors and managers often didn't have a deep understanding of the process either, because they were hired after it was already automated. So the fact that the supervisor managers knew that they were going to have to answer these questions from the young worker meant they were motivated to learn and understand what was happening inside the process. These are examples. It's fairly unclear or fuzzy, but these are examples of the drawings, and the fact that it's not very clear isn't that important, but I think what you can see is that there's a lot of detail, and that these are hand-drawn, and there's a ton of detail. And I didn't go through and try to understand any of these drawings. I just was impressed by the level of detail. And what we're seeing here, again, is what's actually happening to the material. The definition of TPS he gave was to change the shape to the desired shape of the material as it's moving through the process at the rate of customer demand without waste, without any interruption in flow. And they're documenting step by step the process in great detail, and they're seeing the waste. And then what he had them do is to identify sources of waste. One source of waste was quality problems, defects, which led then to rework. And he asked them also to then improve the process based on what they learned from the drawing, and then actually physically make the changes to the equipment. And part of those changes were to actually shrink down the line as they solved problems, and they saw that there was, say, extra work in process inventory, or the distance between processes were greater than it needed to be. He wanted them to move things closer together and also physically change the automation process. So that's kind of unusual in my experience. Typically, the equipment is purchased, and this equipment had the names of vendors on it, and it's often designed, built, and installed by the vendor, and then your company becomes the manager of that vendor. So you need a change, and you ask the vendor to make the change, and you depend on them for improving the process. In this case, the Toyota people were actually rebuilding the equipment and taking ownership of the equipment. What you see here is the quality defects. At the beginning is when he first started the My Machine activity, and then you can see over time a very dramatic change in defects. And obviously there's limiting factors of you can't go below zero, so they got pretty close to zero, and the improvement has stopped, or it's slower. But anyway, this was, again, a result of this relentless focus on the detailed movement of material, and whatever was an obstacle to the vision of perfect flow without interruption. Okay, the second approach that he used was to rescue old manual equipment from a plant in Brazil, which was one of the first plants that was put in Brazil. And again, I'm not positive of the date, but I believe it was in the late 1950s. It was in the period when TPS was really being formed by Ono and his team. And okay, so actually we do have the date. So it was 75 years old, so 25 years before he joined the company. And probably they had an assembly plant there, and their volume was very low. And they put in a manual forging plant for the engines. And because the volumes were low, this had to be a low volume plant that makes a large variety of different parts going through the same equipment. The problem was that when they set up this plant, they quickly became discouraged and believed it wasn't cost effective to have such a low volume plant in Brazil. They even talked about closing it down. And Ono got offended and said, there's no reason why we should not be able to do low volume, high variety production in Brazil and make it profitable. We just have to work hard at it and use TPS. So he took the challenge personally, went to Brazil, taught them about tact, flow, intelligent automation, Junca, how to level the schedule and make a variety of different parts on the same line. And the plant ended up becoming kind of a model for TPS in a machining type process. So this was kind of known within Toyota, kind of a famous line. But at some point, they decided enough was enough. It wasn't cost effective to keep this small plant open, and they decided to close that plant and build a bigger plant. And again, he rescued this plant and brought it to the Hansha plant because he wanted to have a training ground for basic forging. So what he was able to teach using this line from Brazil was the use of smaller, more flexible equipment. It was very primitive, 75 years old. It was highly manual. And he could demonstrate true one-piece flow with very simple mechanisms. And he said TPS originally was without any spending, without any dollars, we're going to use our wisdom to do Kaizen. And he wanted to teach people in the current modern automated plant how to return to the basics of a manual process in order to envision the best way. And in fact, the team has been working on this for a number of years, and they've even taken this very lean line from Brazil that Ono worked on himself, and they've managed to cut the floor space it uses in half and make it much more productive. This is an example of one of the things that they improved upon in Japan from what it had been in Brazil. One of the issues is that because there's a lot of variety, you have to select parts that you replenish on the assembly line, and there's a number of different parts, and it's possible that somebody would grab the wrong container of parts. A countermeasure to that is often an electronic poka-yoke, which is a pick-to-light system. So today you see this all over the place, and not just in Toyota, but where you reach in to pick a part, and the computer knows, because you've done barcode scanning, and the computer knows what part you should pick. And if you break the wrong light curtain with your hand, then maybe a buzzer goes on, or maybe you can't pick the parts, they get locked out. They needed a system like that, but they, again, were told you can't spend money. This is a very simple line. In fact, one thing I should have said is this line actually runs and it makes parts for Toyota. It makes low volume parts. It makes very old service parts, and it does make a lot of variety. So what the team came up with as a Kaizen was what they call a key Kanban, and that is that when you use a particular part on the line, you send back a Kanban, and you see that I'm pointing to this metal Kanban that he's inserting with his white gloved hand. And then he inserts that Kanban into a slot, and then he pulls it, and then the correct cover opens. You can see the cover for that one part is now raised. So he pulls it, and that pulls up that cover, and those are the parts he should be delivering to the line. So the Kanban serves both as a signal, replenish me, replenish part number 8, C, and then also when you physically put it in, it opens the right door to the right parts. Not a breakthrough that's going to change the world, but a very clever solution, and it's teaching these team members about how to think in a creative way, in an innovative way to solve problems without assuming that they need to spend money, without assuming that they need to buy the latest and greatest technology. This is another example. They do kitting for a single product that's made on this line. These are all the parts that are needed, and as you probably know, in kitting you want to have cutout spaces for all the parts, and then when you then look at the kit, if there's a space that's not filled, that's another kind of visual error proofing, that you can see that there's a missing part. Well, in this case, different products use different parts. There's some basic parts that they all use, but there's some parts that some don't use. So there are going to be some missing spaces, even if you fill the kit correctly. So how do you error-proof this? And the answer was that they made these covers that would show that these parts are not going to be used for this product. So expect these. You won't see empty spaces. You're closing off the unused spots. Another very simple poke yoke, another lesson about how we can use very, very simple tools, very inexpensive tools, and the sort of improvements that Ono would have done 75 years ago in that Brazil plant. So in sum, TPS develops people by improving processes. One of the problems with the view that TPS is a methodology for leaning out processes is that we forget that only people can creatively develop the solutions to problems. Only people can define the problems to begin with, in fact. In the process of defining the problems, clarifying them, prioritizing them, finding the root cause, coming up with countermeasures, checking to see if we've in fact solved the problem, taking further action through PDCA, that's how you develop people, and that happens at the Gemba. It happens by actually improving processes, not by talking about process improvement in a classroom. There's a special challenge of developing people in an automated process, and I personally have consulted to a number of process industries like the paint industry and the food industry, and they're sort of at wit's end because they have seen all these lean tools, and a lot of them, like a Yamazumi chart that shows the level of workload of a person compared to the tact, a lot of these don't apply to them except in a small number of jobs because so much is automated. What do you do? And the answer is that you still do the same thing, which is you improve the process, you eliminate waste at the Gemba, but what you're doing is improving a machine equipment-based process instead of a human process. A robot is doing what a human does. A transfer press is still transferring material. A forging machine is still supposed to be doing forging, and that's the only value-added work. But when you look at a forging line, there's a lot of other things happening besides value-added work. And the way that in this one plant, they taught people how to improve an automated process was through getting them to draw the process in great detail, identify waste, make improvements physically by changing the automation, by having to rebuild equipment, by moving equipment around. So it involved manual tear downs. Now, manual tear downs was another thing, is that they also in the process, for example, of doing preventative maintenance, if you manually tear down the equipment and then build it back up, as you're tearing it down, you can understand in detail what's happening with the equipment. And then you can rebuild it in a leaner way using, again, your creativity and innovation. He also would have them manually do the process by bringing a manual line from Brazil to Japan. And it's turning out that his people in his plant are getting some of the best training in the company, in Toyota, in the world in applying TPS to automated processes. And now he's beginning to send the people he's trained to other plants to teach them how to apply TPS to automated processes. And other people from other plants are beginning to come to his plant. It's becoming like a basic TPS university for automated processes. So really what he's done, what he did when he rescued that equipment from Brazil is he was building his university. He was building his simulation, except instead of Legos, it was an actual process, and they're using it to produce real parts. and they're building to tact, and they're leveling the schedule, and they're doing all the things we try to do with TPS. So this case illustrates that lean leadership really starts with a core set of values that obviously this man learned deeply in his 50 years at Toyota, starting with his training from Ono. The true north values of Toyota are stretch and develop people to creatively reach a goal, and that's what he was doing through the My Machine activities. That's what he's doing through having people work on that manual line and make improvements, do Kaizen to that line. And he's had this goal of 2% productivity every month for his whole life and most of his career there. And he's been developing that entire time. Systematic problem solving never ends. They could have taken this line from Brazil and assumed since Ono worked on it, it must be perfect. But in fact, there was lots of opportunity through systematic problem solving to improve it. And they could have assumed that the vendor equipment was the vendor equipment and they couldn't do anything about it. They had to use it the way it was designed, but they didn't. They've been systematically working to eliminate waste in the automated equipment. It has to be done at the Gemba, where you can observe and understand the actual situation. It has to be done through teamwork. It wasn't enough to have one expert in the plant, but he needed to develop individuals. It was my machine, it was not our machine. So each person got a machine assigned to them to draw to work on improving, and that was to develop individuals, and then when they work as a team, you have exceptional individuals working toward a common goal as a team. And finally, the respect is to view people as an appreciating asset worth investing in. And this was quite a major investment, for example, even in just the many millions of dollars of moving that line from Brazil, a line that many would just scrap and do this as a teaching tool to develop people. The model that I developed in the Toyota Way to Lean Leadership with Gary Convis starts with self-development, and he had to develop himself as a sensei working with Ono, and Ono would never answer any questions. He would never tell you anything. He would just ask questions. He would challenge you. He'd grunt. He'd moan. He'd yell. But you had to develop yourself. And that's through repeated cycles of PDCA. And now he's allowing the people in that Hansha plant to go through their own repeated cycles of PDCA. And he won't give them the answers. He just gives them the problem and the opportunity for self-development. And then when you spread this to the point where the team leaders and group leaders have this understanding of how to improve a process, how to see waste, and how to coach and develop others, then you'll develop a daily routine of Kaizen, which then becomes self-sustaining. At that point, you can use something like Hoshin Kanri or policy deployment or strategy deployment, whatever you call it, to align targets and goals from the top of the company to the very bottom of the company. But it all starts here. It starts with individuals developing themselves through repeated cycles of PDCA. And PDCA requires all the steps. You have to plan, and the plan is not simply a strategic plan at an abstract level, but it's an actual clearly defined gap between where we are and where we want to be. That gap is analyzed to understand the root cause, to formulate countermeasures, to develop plans for implementing the countermeasures, and then you try it. You go to the Gemba and you try it. You monitor your progress, modify the plan if necessary. You learn from trying, from doing. And then what you learn, you then put into practice through another step of first standardizing what works, but then identifying the next set of problems to be worked on. So PDCA becomes a wheel that never stops spinning. And the way Ono put it was observe the production floor, eliminate the preconceptions in your mind when you're observing, try to get to a blank mind where you're just looking and asking what is happening and why is it happening this way. And what you're trying to get to are root causes, not root people, not bad people who are lazy and no good and don't want to learn. So you want the 5 whys, not the 5 whos. And what leaders then do at the workplace, which this leader was illustrating incredibly well, was how do we make the process visible, even if it's automated, even if it seems to be hidden from us, how do we make it visible so we can see the problems, then start to think, how can I improve, how can I improve, how can I improve? Ultimately, leaders who we call lean leaders, but what Toyota learned is that what a leader needs to do is to become a coach and a teacher, and the leader needs to manage from the Gemba, like any good coach. You manage the team on the playing field, not sitting in a conference room. The teachers and coaches are teaching the technical skills on how to do a job. You have to understand foraging, and you also have to have a PDCA mindset. You have to understand each person's strengths and weaknesses so you can figure out what the next assignment that will develop that person should be, and then break down tasks to give people the right assignments for them personally that are achievable and challenging. You can get farther by questioning people than by telling people. Once you tell people, then they become obedient listeners and they stop thinking. And this all requires trust. For example, you have to have trust as a worker that I'm not kaizening myself out of a job. So basically what we're talking about is living the values. And you can phrase the values however you want within your company. They don't have to be phrased exactly in the Toyota way, but they do have to include the basic ideas of leaders as teachers, of the spirit of challenge, of teamwork, of managing from the Gemba. So there's some kind of core beliefs and values that are really not that are really not optional if you really want to become an excellent organization. So that's my summary, and again, what I wanted to share with you was what I thought was just very inspiring when I saw this, the Hancha plant, and what a student of Ono was doing to make a very large investment in developing people. And I'm ready for any questions.
Thank you, Dr. Leiker, for your very insightful presentation. We have one question that was submitted early on, and that is, how long is the spread lean phase?
Forever. Because the problem is that things change. That's the problem and the opportunity, you might say, but things change. So if I were to go into a process, one of the companies working with now is a mining company, and we're working with them on the maintenance and overhaul process of equipment in the mine. And one of the things they started with on their own, and we're going to continue with, is they developed a preventive maintenance cell for changing tires, which can be like 12 feet tall. And they have developed a really nice process with carts, and there's parts in the carts, and it's a shadow box, so you remove a part, and you'll see that you're missing that part. But in fact, there's a lot of different equipment, and new equipment will come in, new ways of attaching tires will be developed. There'll be new part numbers, and those carts will be out of date. So if they don't keep improving the process will become out of date. Then they won't have the right spaces for the right parts, and then people will start putting things in whatever spaces they can, or they'll stop using the carts altogether. So that's the entropy issue. And in addition to that, people who are assigned to that tire job are also on call for breakdowns in the field, and that will take priority. So there's constant churning of people in and out of that cell, and the more of those cells we create, the more churning will happen. So they'll be constantly in a mode of developing people who understand the standard process for preventative maintenance so that they can send the right person into the field when a breakdown occurs, which they can't predict when that will happen. And that will be a constant process. And the leaders who understand lean and who are leading Kaizen will also be promoted. They'll leave, and they're going to have to constantly be developing the next generation beyond them and replacements for those people, or they'll end up with a set of leaders who don't understand or believe in lean. So organizations are very dynamic technically in the raw materials you procure, and in the people themselves. People just move and change. And so, but if you wanted to spread this throughout, like in our case, if we want to spread this throughout maintenance so that everybody in maintenance is following something like lean procedures, and they have most of their preventative maintenance in cells with standard work and standard carts and all that. I mean, that will easily take a couple of years to kind of spread it across the whole mine if they're serious about it. And then they'll have gone through the first wave of PDCA. We've got one wave of lean stuff every place, and people are beginning to be trained, and then you keep on improving and improving and improving. We worked with one mail order operation in Ann Arbor, started 10 years ago, and they just completely reorganized the whole warehouse within the last 3 months, almost starting from scratch, so it never ends.
Very good. We have a number of additional questions. The next one is, are there any effective ways of measuring team engagement and ownership? Because first of all, the term effective, I would always ask is, by what criteria is it effective? So you have to define for yourself at a particular point in time, what is your next target? What is the next level of engagement? Because mostly when we look at our organizations, people are not very engaged. And they're not engaged because there are not standard processes to be engaged in, because there's not good ways of training people going on. So the conditions of engaging people are not present. So you have to, piece by piece, build the puzzle so that you have a system in which that engages people. So wherever you are, you have to ask, what is my vision? You can define your vision, and then what do I want to accomplish next? For example, do I want to have standardized work on 25% of the jobs, and do I want people to, do I want the supervisors to own the standard work and be training to it and auditing it and improving it based on suggestions? And then that becomes something you can measure, and it's a target. Or do I want some number of suggestions per person per month, which some companies do, and that could be another way. That's just trying to get people's brains to be lubricated by coming up with suggestions. They may not be the best ideas in the world. So you have to kind of measure what you define as your target and how we're doing compared to that target, and the target should keep on being changed as you evolve. Having some generic questionnaire or survey of employee engagement, to me, is not terribly useful. Okay, third question. How long is the average training time as described in this presentation?
Well, these guys, I mean, to do one machine like that would take them, and to make improvements in it would take them a few months, whether it's 2 months or 3 months or 4 months or 5 months. It's going to take them a few months, and then they will have made an improvement. in the machine and they will understand the machine. I would say that somebody who came into that plant now, the way it's set up, they're going to learn a ton in 1 year. And in 1 year, they're going to have a level of understanding as a maintenance person, as an engineer, beyond what they would have in most other plants that they could work in. So you can learn a lot in a short time, but from the point of view of this 50-year veteran, he'll view them as complete novices even at the end of a year. And he would say he's still learning after 50 years.
Okay. Fourth question, at early stages of lean implementation, how important is it to quantify savings when chasing waste, and how can you see productivity improvement when implementing lean?
Well, in this case, this guy was simply told by Ono, I want 2% a month. So in the first month, he got 2%. However they measured it, they were measuring it based on labor hours per some quantity of forged parts. And so you can measure productivity, and productivity is always measured as the input required for some output. And depending on what you're trying to do, you'll have different measures of input and output. But the importance of quantifying the gains, again, that question is kind of fueled by my first model, which is lean is like a machine, and our processes are like machines, and we're trying to lean them out. And we're doing something to the machine. We're taking a wrench and we're tightening something, and then we want to measure it by tightening it 25 degrees. We're going to get a 1% improvement in productivity. The fact is that any system, even an automated system, is not a machine. It's a human technical system, and you're trying to improve the capability to improve, not simply improve the process itself. The answer is, should you measure in the early stages return on dollars spent, is that it depends on whether your senior management requires you to do that. And if the senior management believes in lean, particularly if they've had experience with it before, and they know it's the right thing to do, they might walk in and say, hey, look, and I've seen this happen, in this first year, we're going to pick a model area. I'm assigning some people to learn lean, and they're going to work in that model area. We're also going to do 5S. We're going to clean up this place because it's a mess. And I don't care about savings in the first year. We're not going to spend money. We're going to spend time and energy, but I'm not buying a lot of stuff. I'll buy paint. I'll buy tape. But we're going to get started, and I'm not going to measure you because I want you to start to learn. That's what a good lean leader would do in their is likely to do in the first year, unless the company is on its deathbed. In a turnaround situation, which we describe in the Toyota Way to Lean Leadership, which was after Gary left Toyota, he became the CEO of Dana, a part supplier for trucks. And they were coming out of bankruptcy, and they had to meet covenants, that's agreements with the board that from the bank that ran them. They had to meet those covenants by the end of the year, or they could be shut down and dissolved as a corporation. That was do or die. So in that case, it was very important to measure results. They didn't have to measure results attributable to lean. They just had to measure results so that they could save the company. And the lean projects had to produce results. So that was a particular situation. So it really depends on the situation you're in. In the ideal situation where you were not on your deathbed, the company's healthy financially, and you have senior leadership who believes in lean and understands it. In other words, the way I put it is they want excellence and they're not satisfied with mediocrity. In that case, they're going to view the first year as getting started and beginning to develop the know-how for improvement, and whether it shows up in the bottom line of the company or not won't be all that important in the first year.
All right, one final question, and that is it possible to get copies of the My Machine drawings?
No. I mean, I have what I have, which is the photos, but that are in the presentation, but I didn't ask for copies of the drawings, and
Okay.
I don't have them.
Well, thank you again, Dr. Leiker, for your presentation today. This brings our webinar to a close. Our next webinar is scheduled for December 12th on 3P product design, innovating with lean tools. Please visit ame.org/webinars for more information and to register. And don't forget to fill out the short survey that will be in your inbox after today's webinar. Thanks everyone for attending, and have a productive day.